I have a mic as well, so I can repeat some of the questions.
Oh, okay. For everybody that's here, I'm Randy. If we got any questions as we go, just holler them out and we'll jump around. It's not a big deal. So basically we're gonna have two identical systems. And the conveyor up top is gonna either drop into one or the other, the way it sounds. And we'll kind of follow this, and everybody's got the same here to a certain point. Not all of it is done yet, or all installed yet, but we'll just go as we go here. For the general operation, basically you're going to have the power pack right here on the bottom with the two control panels, the inlet feed hopper up on top, the main drum, the collecting conveyor underneath, and then the discharge is going to be on that side running into the other set of conveyors to run out. And basically everything's going to run off a remote control, but we're going to run through the manual side of it. Basically is what we're going to do, because that's all we got set up right now. If we close this panel so we can see the switches here. Basically, once they give us main power into the control box here, you're going to have lights lit up. You're going to have a key switch that's going to run either remote or manual. Remote is going to be from the computer panel in the main control room. That's where you guys are going to run the majority of your time. Today we're going to run basically on manual. So we're going to hear the manual light would normally come on now. And then you can run individual functions down here, basically three functions. One is the conveyor itself, the hydraulic pump system down here, and then the actual de-stroker valve, which is the drum, turns on. We don't want to turn the drum on the same time we start the big electric motor because it takes too much of a draw. So basically we'll start the big motor first so we have power available, and then we actually turn the solenoid on to put power up to the two motors to actually turn the drum. So basically you'd have the down system conveyors already running. So you'd have the conveyor running that way to the computer already running. Then, and if you're doing it manually, you'd start this conveyor, the light would come on, which would dump into this conveyor, which would be already running. Then you turn the pump on, and then you turn the actual drum itself on. Each light will come on as the function starts up. We're going to have a total of 4 e-stops installed. One is on the panel. The other 3, you guys have to decide where you want them on the machine. So that's all, it depends up to your safety committee or whoever decides on that. Each one will kill the complete system. Both systems, 1 and 2, are identical. So whatever's on this one is exactly on that one over there. Basically, as the material comes in, and we'll have all that done, there'll be very little adjusting after the fact. When we come down for the production test, we'll have all the angles and so forth adjusted for the drum. So part of that is actually in here, so we get enough material in the drum to get either increase the angle or the speed of the material coming in and out. But we still put it in there because if you read it, it's actually very self-explanatory. But basically, we want the material to come in, and we want to use as much of the drum, the screening area that's available, without having a lot of fines go out and reject in. So if we're not using all the drum, or say the material is falling in the first half of the screen, I think there's 7 panels. So say the majority of the screening, the good stuff coming out the bottom is falling in the first 4 sets of screens. We can actually bring the incoming feed faster to get more production out of it. If we're using, say, 6.5 screens, and we're still getting too much fines going out the other end, then we can either lower raise the other end up so we have less of an angle so the material stays in the drum longer, or slow the infeed down a little bit so it has more time in the drum. So and like I say, we'll kind of take care of all that when we actually get material running through it. And I know Tim's coming down for it. I'm hoping I come down for it too. Whether I'm driving or flying, it don't make no difference. So we'll, like I say, a lot of it we'll actually take care of at that time. But we'll just kind of explain it a little bit.
The rotation's fixed, right? The
Rotation's
speed-
fixed, yep. We can adjust the speed of it right here.
Okay.
We'll kind of do all that, unless you're gonna change materials every couple of days,
Yeah.
we'll have sort of all set and it'll be a done deal. If we need to adjust it, we can do it here. And basically it's a 0 to, I believe, 22 RPM.
Where are you planning on running at startup?
We'll probably run at about 18, 16, 18, somewhere in there.
It's like 90%.
Yeah.
Okay.
Yep. We want it so that, I'm not sure if there's a picture in here of the drum. No, there is not. If you picture the drum itself as a circle, if you look at the end of the drum from the discharge end, you want the drum to run fast enough so it picks the material up and drops it off about, say, about 11 o'clock and drops it at about 4 o'clock. That's what you're using about 80% of the screening area that's possible. If you go too fast with the drum, the material will actually carry itself all the way around and it's not doing any good. On certain materials, we've actually found that it's actually better to go real slow and get more of a tumbling action than a throwing action. Like I say, we'll play with that when we get the material at the production test. But basically, that's the 3 different things you can change. Either the material coming in, the angle of the drum, and the speed of the drum. That's the 3 variables that we can play around and get the maximum production with the maximum fines out of it. See, you got 3/8 screens, I believe, installed on this one.
3/4, 3/8.
Okay, I thought they were both 3/8, whatever. So, like I say, we'll kind of play around with that when the time comes. But basically, that's your 3 variables.
How would you account for if sometimes your material is extra moist? What effect would that have on all your adjustments?
If it's really, really wet, are we talking like 70-80% moisture?
Occasionally it'll be wetter, probably seasonally. So we were just planning on slowing down the feed a little bit.
Yeah, that'd probably be your easiest, because that's probably the easiest control from the control room.
Yeah.
Yeah.
It's a speed feed, instant modifier.
Yes. Yeah. You're probably going to lose a little bit in production, but if we're talking, if you want to run, say, 50 or 100 tons through it, and it goes back to where you think your average is going to be, that's probably your best bet. Because if you got too many guys coming over here, changing pulling pins and this and that, and changing variables. Yeah. And like I say, I'm just a phone call away if we have problems.
Pardon me?
I'm just a phone call away if we got problems. So that's not a big deal. So basically, once the material gets in, the brushes are going to be located inside, and we're going to try to get some of the maintenance guys go up with the boom crane and take a closer look at them. But basically, what they're going to do is they're going to stick through the screen about 1/8 of an inch. The more you stick through, the faster they wear out, but you got to have them sticking through far enough to knock the material down. Now, the drier the material is, if it's real dry, we can actually back them off so they just basically touch it a little bit, and they'll last forever. If they're real wet, you gotta have more brushes in. It's just a wearable thing. And they're basically all adjustable all up on top through a little, like a little turnbuckle type setup in there. We'll go down when we get a little closer up in there. There's basically 4 trunnion wheels that the drum rides on. You can kind of see them up on top here. They're like a real big, wide forklift tire. There's 1 on each corner, and then on the other end down there, when we go down there, there's actually 2 thrust wheels that actually hold the drum from sliding that direction because of the angle that we're running. That's on, well, I guess we have no page numbers on here. Those are actually on the thrust rotor replacement. Basically, there's just 2 little wheels that the drum runs on to take the downward pressure. There's really going to be no adjustment on the 4 trunnion wheels themselves unless we have to replace them. And basically, to replace them, take the coupler part up on top here that connects the gearbox to the wheel, to the shaft, and then we'll have to raise up the drum itself. You don't have to raise it up more than about 3/4 of an inch.
How do you do that?
With a hydraulic jack. Basically, you put a jack underneath it. There's a cross tube going across it, and you just put like a 20-ton bottle jack underneath it, raise the drum up.
Where do you push? Right where the rollers track? Right on that?
You can either push on the outside and push it this direction, or you can put it almost straight up.
You can push anywhere on the drum?
Yep, anywhere on the drum. Yep, yep. Like I say, there's a tube running underneath. So we put that in there so you can actually put the jack under to push on. You got something to push against. Otherwise, you'd have to come way down to the main frame, which you can still do with like a 10-ton quarter power.
Okay.
We've got that way too already in the field.
Okay.
Basically, once you take the two couplers off on the shaft, and then there's 4 bolts holding the 2 bearings on. You take it all out in one assembly, throwing it on the ground, unbolt the hub or the shaft from the wheel, take the wheel off, put the new one on, just like changing a tire on the car.
How long do you think it'll last?
Most of them we've got them on, they've got thousands and thousands of hours on them. It's not something I see as a wearable item. Let's put it that way. Hour-wise, I guess I can't give you an honest estimate. There's 2 things that make the wear on the tires, and that is heat and time running.
Just curious.
So, of all the screens that we got out with these big tires on it, I believe I've only replaced 1, and that was about 6 months after we started, and I think that was more of just a defective rubber, because the actual rubber came off the tire.
That's the bigger problem with these, that rubber types come off.
Yeah.
But these things are so far out of the debris. I mean, usually it gets stuff caught in there is what screws it up.
Right.
So as long as we keep those clean.
Yep. And that's where the maintenance screw kind of comes into effect, is how they keep it clean around it. Okay. And that works on bearings, couplers, hydraulic motors, hoses, that's everything. So, basically the 2 conveyors, just like all the other conveyors, going to have a head pulley and a tail pulley. The head pulley is going to be fixed. The tail pulley is basically made to adjust how tight the belt actually is. In fact, why don't we all kind of go around this direction to the rollers. Now we can actually take a couple panels off if we want here. But behind this panel are the actual rollers. Here's one here, you know, every roller on the top, and they're a troughing roller, just like you got up on the other conveyors. The bottom return idlers are all flat. So basically the easiest way to track a belt is, now this one here is just about, could be a tad bit tighter, but not too much. You want enough slack in them, so if you pull them too tight, basically you do 2 things. You put too much stress on the splice, and it's gonna come apart or rip it apart. The other thing is if it gets too tight, the rollers don't steer the belt like it's supposed to. Probably the biggest thing that most people think is the tail pulley does all the tracking. That's actually the farthest from the truth. On a short conveyor, that's more true than a longer conveyor. The tail pulley is made more for how tight the belt gets. The rollers up on top, it's just like a steering wheel in the car. If you take this side of the roller and push each one ahead a little bit, and it don't take very much, I mean just a half a degree, it will drive that belt to the right. If you want to go the other direction, you can bring this side backwards or the other side ahead. Now each one of these got a slot in them, so you can move actually each roller about 3/4 to 7/8 of an inch.
All of them, or you have
All
one
of
that's
them.
this?
No, all of them. And so when we actually go down to the actual tracking them, now we're going to track them empty.
What he's asking though is one roller will track it, or every one
Well,
needs to be moved
I was just going to about to get to that.
Okay.
With each roller, weight has a little bit of effect on it. So once we get to production, we may actually track them again a little bit again after the fact, but we'll track them empty. Each roller, you can do it with 1 or 2 rollers, but if the weight coming off the screen is very erratic, the more if you have a bunch of weight on one spot, you got a roller here and a roller here, and this one's cocked real big and this one's not at all, as soon as the weight hits that roller, it's going to want to steer in one direction. But now as soon as the weight gets to the second roller, it wants to steer the other direction. So all of a sudden we're going to try and go like this. That's not a good situation.
A bunch of friction then.
Right. And what's it going to do is it's going to do 2 things. It's going to make the belt go at a snake. It's also going to wear out the bearings on the one roller that's doing all the work faster. So you're better off, I try not to adjust it more than less than 3 rollers. The more you do a little bit, the better off you are. So let's say we were an inch off the head pulley up there. Say it was driving to the right-hand side. It was way off to the right-hand side. So we want to move the belt to the left-hand side. So what we want to do is either take this side of the rollers, and I generally would start on the head pulley end, because in this case, the majority of the material is going to fall on that end. So that's where we want to start there. On a regular conveyor, I would start from the tail pulley end where the material drops in. But in this case, we're probably 80% of the material is going to fall from here on the head. So this is where most of the weight is. So we want to start from the head pulley and tap each roller back less than 1/8 of an inch. And what I usually do is as the material runs, take a hammer and we'll loosen up the bolts a little bit, and we'll just tap each one a little bit and watch the belt go, and just go to the next one, the next one. If it takes 3 of them to do it, or if it takes 5 of them to do it, them 5 are way better than 2 up front. Like I say, if it wants to go the opposite direction, then we'll move these ahead then. If we want to go the opposite, basically. It's just like a steering wheel. If you turn the steering wheel this direction, it's going to move the car this way. It's going to move the belt the same way. Same thing. Now, to adjust where the belt runs on the tail pulley, these rollers here would do that. The exact same thing. The only thing to remember is, instead of looking up on top, you actually got to look from the bottom up, the direction of the belt. So since the belt is going this direction, and say we want to track it to the right-hand side of to the tail pulley, we've each got to take this guy and either move him back or that side ahead. Most guys will think that it's just the opposite, but you're looking from the top inside the belt down, and you got to actually look from the bottom up. Always look at the direction of the travel of the belt. If the belt's going this direction and you want to go to the right, you either got to bring this side of the roller back or this side ahead. Real simple. Like I say, majority of that we'll have all done at the production test. The chart on here for the daily maintenance, way in the back I think here. There we go. And I'm assuming that's the 3 guys that'll probably do that on a daily basis, the 3 or 4 guys. Basically, belt tracking, the screen brushes, and hydraulic oil level. The hydraulic level is a sight glass in the back side here, which we can take a look at a little bit here. The brushes basically are the brushes all contacting on the screen itself. Are they actually cleaning the screen? If they're not, then we need to adjust them down a little bit. If they're wore out, then we'll need to replace them. Pretty simple. On the weekly or basically in the weekly, we'll kind of do, once it gets aligned the first time, and it actually is, before we leave for the production test, we're all said and done that, we'll actually check the alignment of the coupler between the electric motor and the hydraulic pump. It's basically the Lovejoy coupler. And that's just a matter of opening up the cover and checking to make sure that the rubber didn't come apart, both halves are still in line, set screws didn't come loose, the whole 9 yards. Pretty simple. All the other stuff is all pretty, just basically come across, check hydraulic fluid, so forth down the line. The bearings that are greasable on here, there's basically, you're gonna have 4 on each wheel. I don't know if we can see them or not here. Yeah, you can kind of see them a little bit up here. There's a bearing on each side of the thrust wheel. Okay. Each one of them is gonna have 1 greaser. Yeah. Every $500 is what I was thinking it was. Basically about 2 to 3 pumps with a hand grease gun. No, I don't know if you guys use air grease guns or not. We don't like to use them at all in bearings because you can't tell how much is actually going into the drum. So, basically you're gonna have 2 bearings on each wheel, and then you're gonna have 1 on each supporting smaller bearing on the shaft that actually runs the wheels. It's actually a 4-wheel drive drum. So all 4 wheels actually drive the drum itself, not just the 2 front ones. And you've got the same one on this side as you do on the other side. As far as the drum greasable points, that's all that's up there. On the collecting conveyor down here, you've got 2 bearings on the head pulley. And the one down here, Yep. And then you've got two of them down here on the tail pulley. I didn't know which tail pulleys you guys had ordered on the quote. So basically, you've got 4 grease points on the lower conveyor itself. That's all the grease points there is in this whole machine. Each panel you can take off, like I said, to get to each roller. They're also used as finger guards, so you can't get your fingers in the belt and so forth. The actual hydraulic valve, if we ever need to adjust this machine, the angle of the drum itself, we'll need to loosen these 2 bolts up. Then on this side here, it's all hydraulically driven, but there's a hand valve over here. Basically up and down. And what that does, that runs these 2 cylinders up and down. You pull the pin out, come down. Looks like you guys don't want to come down any lower than this because you welded them off. So I'm assuming whether you're going to use this hole or this hole. I believe there's one more hole up here yet. Like I say, we'll have all that done at the production test. If for some reason we need to change it, that's what we'll end up doing.
That's the angle?
That's the angle, yep.
Is there like, if you know where this is, that's 7 degrees, or is there any numbers on it? You know where you're
No, there is no numbers on it, no. Of course, I don't have the angle finder with me. I would in the truck. But if we put the angle finder on, if you actually want to know the actual angle of the drum, I would say right now we are probably running at 5 degrees.
What's the average?
Between 5 and 6. Yep.
So if we move this in, do we need to move that in?
No, that end is stationary. It's all on a pivot point up there. So all you're going to do is you're either going to drop or raise this end. That'll give us our angle. Everything's hydraulically driven off the cylinders here. All you got to do is we got to pull 2 bolts out for the extra support
And a pin.
and 2 pins.
Those are big jumps here. I mean, if you want to move it, you got to, that affects it by what? Couple degrees?
No. Actually, only about a little over half a degree.
Half degree then, 6 inches.
Yes. It looks like it's a big jump,
Yeah.
but you're talking 40, 42 or 43 foot. Well, the drum is 40, but the framework's longer. So you take it over a 40-foot span, 6 inches is nothing. So, any questions so far? All the bearings right now have all been factory greased for the first 100 hours. So some of the guys that didn't see it before in the picture, here's the 2 thrust wheels that were shown in the picture there. I don't know if you can't really see it. That's the 2 thrust wheels, and they will actually pivot a little bit as the drum turns.
That's why it's inside of a tube there.
Yep. It'll move very, very little. And that runs on that ring, which goes all the way around the drum.
Right.
And that holds the
That's
force.
'cause they can't get that ring bent completely flat.
Right. In the perfect computer world, it is.
Yeah. Then you weld it,
Yep.
and then it gets out around and out of flat.
These here will probably be, that thing will probably move about 1/4 of an inch back and forth.
Step away to take that handle off.
We can pull the pins out.
Yeah. We're gonna have to.
Okay, that's up to you guys.
We'll speak to you later about it.
Okay. Yep.
Also on this elevation change with this, you'd have to loosen these bolts right here, right?
Correct. Yep.
Yeah.
And then when you go to the next hole, then all the holes are made to match up to all the holes here.
Right.
We put the center piece in here. It gives a little bit more stability side to side as the drum rocks. As it's throwing that material around on the drum inside there, the drum is going to want to rock a little bit.
So you got an anchor in the center right there.
Right. It gives a little bit more stability.
Yeah.
What's the purpose of the plate? To cover up some holes, or you never need to go that low?
Well, you guys covered that up at yourself, so I'm assuming you guys either it comes too close to the hoppers that you guys built for back here, is what I'm assuming. So they wanted to put it so they physically cannot bring that drum down any further. Your guys did that. I guess I'm not aware of it. I'm assuming that's what it is, so the drum can't come down any further than this hole. Because that's the lowest that those, otherwise you'll smash the hoppers on this next conveyor, is what I believe it is. Basically, the material itself,
I don't think so.
it's pretty dark up in there, but you can kind of see the outline of the brushes on that side over there. Through the screens up there.
Just above that bracket?
Yep, right above that angle iron there. Like I say, we'll go out the guys that actually got to work on it. We'll take them up in a high lift or whatever and go up there. Basically, I think you said we got 3/4 inch screens on this one. Oh no, these are 3/4 on this one. This must be 3/8 on this one then. Basically, the drums are identical other than the screen sizes. So, that's the smaller ones there, that's 3/8.
Yeah,
This is 3/4.
that's what it looks like.
I'm assuming the first time it's gonna run, you gotta want to run through the big screen, get all the bigger stuff out, and then the next patch you're gonna run through the smaller one.
I thought it was a one-shot process, but
Yeah.
it's supposed to find out.
Or maybe they want two different finished product sizes.
Maybe so. Where are these brushes at now? You were talking
Right.
about?
You kind of see them right there?
On that-
Yeah.
Okay.
Like I said, we'll open up some of the doors on the side there, so it's a little easier to see from the outside with the lights in. But basically, as the material comes through, what we're looking for is basically, so it picks it up about 11 o'clock position, about right there, 10, 11 o'clock, and throws it down to about, 4 or 5 o'clock position. That gives you your most screening area per revolution. So, and that's where our angle and with the material coming through, the speed of a drum is going to affect how fast and where everything drops.
Which way does this thing rotate?
It should run, let's see, it should run this way. We want the material to run so it comes up the top and drops before the brush is pushed through there.
Okay.
If it goes backwards, it's going to want to, the brushes are actually going to want to push the material out before it actually has, gravity has a chance to pull it away and drop it.
Right.
What are the bolts for running down that support?
They're actually two sets of bolts. The other set of bolts you can't see down below here, they're 180 degrees apart. That's the two screen halves around the drum. So basically they come around to one side and they hook, and then they come down around, and then that's the tension rods that actually tension the screens around the drum. So if we ever want to change screens, we take this outside housing off up on top, we loosen all those bolts up there. In each section there's seven sections. So there's actually 14 screens total. So on each section, which would be, from, I don't know if you can see from the light there, from there to the right there, that first heavy ring there,
Yeah, I see
that's one screen.
Yeah.
So on that one section, there's a screen, half screen on this half and one on this half. So,
Do they ever vary the sizes of the screen in the
the length of it?
yes.
Yeah, sometimes they'll run with a bigger screen up front and a smaller screen behind.
Right.
Yep.
Okay.
It all kind of depends on the material coming through, what's acceptable out as far as in the fines and on the reject side.
Right.
So if you want to mix match and put in, since there's 7 sets of screens on there, if you want to go with a smaller screen first to get the real small stuff out, or the bigger stuff out first, and then almost make a different product, a different product screen every time to keep the material through it. That's something we can experiment with after the fact. We make screens from basically a 1/4 inch up to 1.5 inch. It's pretty standard or stock for us.
Ultimately, we're planning on making these identical, so we got redundancy, and we'll do a combination, probably 3/4 the first couple of sections, 1/2 inch for the center, and then 3/8 in the back,
yeah.
and that'll make sort of a true 1/2 inch. Because you can imagine in the beginning of it, there's so much material piling on top of itself that really only a teeny fraction makes it through. So to get better production, you can put a larger size up front and still get the size you want.
Right.
They have different screen cloth in them right now, though.
Yeah, 3/8 and 3/4, and then I bought an extra set of 1/2 inch because I'm planning on, after we learn our production limitations, using a combination of all three sizes to make a true 1/2 inch or 3/8 depending on what our material looks like.
Right.
So we'll run for a few months and then we'll call Peterson in or something and swap these out so we got redundancy. That's our goal.
Good.
We just
Yeah.
don't know yet, and we didn't want to limit ourselves to having only 3/8 because what if our material takes too long to get through a 3/8 and we have to run the facility 15 hours now? That's why we know we can make it through. We can't have any bigger than 3/4 and put it to market.
Right.
So that's why we have the two sizes. So we didn't have a bottleneck here at startup.
once we find out what the actual incoming product is, that's going to determine, you know, screen sizes. So.
And probably moisture.
Oh yeah.
Yeah, big time.
So. Other than that, any questions?
How do you adjust the brushes?
We'll actually go up on the side there and do that. There's actually a little turnbuckle up there to hold them in and out.
What's your screen style? Is the end of it hooked and then
Yep.
there's a tensioner?
Yep.
So it cinches it up?
It's all hooked on one side, and it comes around and bolts in the opposite side.
Okay. So is there like amount of torque, or you just do it by feel, or?
Basically, we want the bolts tight enough so that the screen pulls around the drum tight enough, so it doesn't have bulges in it. But if you get them too tight, then it'll actually sag in between the ribs.
Right.
So right before it starts sagging in the ribs, just so it just pulls it down in the ribs a little bit, that's where you stop.
Okay.
And that might be a little easier to see once we get up on top.
All right.
How many total individual screens are in this?
14.
14.
Yep.
All halves.
Yep.
7 on this side, 7 on the other.
Right. Yep.
How many hours would it take to change all those if you wanted to go and do all the screens? Two-man crew or, you know,
3 is actually better.
three guys?
Yeah. Yep.
A full day?
What's that?
A full day?
Depends if you use an air wrenches and how fast they work. It's gonna take a good full day. I don't know if you'll. First time around, I don't think you're gonna get it done in one day. The other thing you got to worry about here is to get a boom crane in there.
So you're taking a crane?
You're right. You know, so
This is going to be interesting to try to get a boom in.
Yeah. So there's no way to get a boom crane down in here, is there?
I don't know what we're going to. We can go. I think we can get a boom, a street legal boom around the other side, and we're just going to have to come over here with a stick, and it's going to be interesting.
The other possibility is, depending on the structure of the roof, you might be able to put like a little I-beam rail, like a hand hoist. Right
Well,
above,
this is
right above
just a
the
drop ceiling like in an office building.
Oh, okay. Well, then that won't work.
Yeah, but it's not impossible. We could fix some sort of. I hadn't thought of that.
Like a horseshoe. You know.
Okay.
Because basically, if you have one down the center, then you can pick the screen up and bring it out here and set it down, and take the next one back up. That's all you really need.
Oh, pretty heavy, one screen.
Awkward.
Yeah, probably about 400 pounds.
Oh, you gotta have
450? Yeah. Now the smaller screen, like a 3/4 screen, is not near as heavy as a 3/8.
A lot more wire.
A lot more wire. Yep.
What are you thinking on life on this? With all the extra ribs and the support on that thing, I mean, we should get over a year, I would think.
On the screens?
Yeah.
Are these regular mild steel, spring steel, or are these stainless?
No, spring steel. Or I'm not positive about that. I'm fairly certain.
I think they're just regular 12 gauge steel, 12 gauge spring steel, I believe.
Right. I think we'll get a year. I'm hoping because of all the supports. I mean, hopefully we get a little longer than that even.
I'm thinking you're going to get a little longer than that. A lot of it's going to depend on the material coming into it. If the material is going to be more pH levels or more acidy, it may rust.
We'll be a little alkaline actually.
Okay.
High 7s.
Okay. So, I would say you're going to gain a year real easy. I wouldn't see why not.
Okay.
But there's too many variables where I could say it's going to last 5,000 hours, 1,000, 10,000.
Okay, fair
Too many
enough.
variables.
Fair enough.
So, other than that, any questions?
What's the general lifespan of those drop rollers underneath?
On the conveyors?
Yeah, they're reasonably.
About 18 RPM.
We got a
So
lot
not
of them
that
that
slow.
have got over 5,000 hours on them already, and they're still running.
Because I know you're looking at a pretty dusty environment down there.
Yeah.
But they last pretty good.
Oh yeah, yep,
Bearings in them, whole
yep,
lot.
yep. They'll last just as long as any of these other ones. In fact, I think they're actually the same brand. PBIs. At least the conveyors in the other building were that way, and we use the same rollers.
And of course, what about the brushes up there in the corner?
The brushes, unfortunately, there's too many variables for how long they actually last. the further they poke in, they wear out faster. But if they don't poke in far enough, if the material is dry enough, a lot of places actually don't even use brushes at all, because the dry material does not stick to the screen cloth.
Right. But we're likely going to be dealing with a little bit on the moist side.
Right.
So what's ideal depth for poking the brush in, whatever it needs to?
Basically about 1/8 of an inch. We're actually going to run, when we do the production test, we're actually going to play with it. If it knocks the material out, we may actually back them off a little bit so it actually just kind of touches it a little bit.
Right.
And sometimes that's all it takes.
And those are individually adjusted or as a group?
As a group. I believe since we're a 40-footer, I believe there's 2 groups, I believe.
So if you eventually had screen in there that was like a staggered progression, like 3/4, half, 3/8, the same rollers would be able to be adjusted accordingly?
Right, because the screen cloth, no matter what the opening size is, the screen cloth is still round, 8-foot circle.
Right.
So the brushes are still going to poke in, whether it's trying to poke through a 3/8 hole or a 3/4 inch hole. There is no difference as far as where the screen actually runs on the drum.
That makes sense.
So, and like I say, we'll take the 3 or 4 guys that are actually going to do the maintenance on it, and we'll run up with the sky lift over here and take a couple bolts off there and take the panels out and look at them. Or however many people want to go up there, I guess.
Right. So there's hydraulic power running to the
No, a shaft. It's a direct coupler shaft all the way from front to back.
And the middle is supported by what?
Nothing.
Nothing. So the drum's rigid enough to
Yep.
just carry the weight. And
That's where those, what is there, 12 angle irons or 10 angle irons that run the length of the drum?
Yeah.
That's your longitude strength in there.
And that's accounting for the weight we spec that's
Yep.
going to go through it.
Yep. Basically, each brush, you can kind of see where they're just poking through just a little bit. Like I say, on 3/4 inch screen, it don't take very much because the hole size is so big. But basically, I believe is it all in one or is it 2 sets? 2 sets. The front half is on one set of brushes. They all adjust at one time, and then the second half. But each individual brush, how do I say this here? This guy will adjust all of them at one time, and this one here will do individual ones. So once every individual one is set, then you can do basically all 2 turnbuckles. Yep, one about second door up. You can just barely see it in here because it's pretty dark in there. Oop, here, I'll let you up front here. You almost had a flashlight. So then basically to change them, and basically the rake teeth are in here so to keep all the plastics out, which you guys won't have a lot of. But that's made so that as the brush goes down, it tries to get the plastic out and drops it down here. But basically, it's just a 2-bolt bearing on it.
Seal bearing?
Yep. Yep. There's no greasing up on top whatsoever.
So on replacing these screens, does this whole thing have to come off?
The top half on bolts are in sections. You see each section is bolted together.
They have to come off here, right? This whole,
Yeah.
oh shit. I don't know how they're gonna do that.
You can do it. It's a lot tougher by just taking the top panels off because everything's bolted together,
Right.
and then putting the screen down in there. Yeah, you can do it that way too.
Yeah.
But it sounds like they're gonna have that all contracted out. So
That's good, I guess.
yeah, and they'll have just enough room up here to get the boom crane up here, so it should be okay.
Yeah.
And because each roof section has a hook up in the center. All you gotta do is put a clevis on it, it pulls right out of there.
So these just roll with the turning of the drum.
Yep. It actually, like I say, it actually runs. As the brush comes around, just like the wheels do in the bottom. The wheels are a driver. In this case, the drum actually drives the brushes. The plastic. They're that kind of that poly bristle, or what do they call it?
Okay. Now, did I need to we have to take the top of this thing off in order to change out the screen?
Ideally, yes.
Does that leave here up?
Yep. With everything bolted in sections. Yeah. There's a hook. We put a hook in the center of each one. Put a clevis in there and pick it right up.
I think I'll just play it safe and call off safe when we get it.
Yeah. The other possibility, like I say, it'd be a little tougher but you could actually take off the panels
Oh, yeah.
and leave the angle iron frame, and you could probably get the screens in, especially a lighter screen.
Yeah. This is 3/4?
This is 3/4 inch 12 gauge. Now if you went with like a 3/8 7 gauge wire, you'd have a tough time. Because they're gonna be real stiff, real bulky, they're not gonna bend, and they're gonna be heavy.
Now, did I hear you correctly? One screen, 1/4
Depending on what size you are. Now you've got the lighter screens.
Oh, okay.
You've got the 12 gauge wires, and like 3/4, this one here probably weighs 180, 200 pounds maybe. Two guys can pick that up real easy. Oh yeah.
Okay.
These are going to be pretty light. Now the other ones that are 3/8 are going to be heavier because you're going to, you have a smaller opening, so you got more wire per screen panel.
Now, with these spinners and everything, do we have greasers and stuff? You gotta
No,
grease?
these are all seal bearings up here. And like I say, the rake teeth are made, which you guys probably won't use too much of, but a standard for us is on the compost that comes in that has a lot of plastics in it. When the plastic gets stuck in the screen, it gets stuck in the brushes, and that cleans the brushes out of what it does.
Yeah, okay.
But in your guys' case, you won't see too much of that, the way it sounds. So basically, like say, if one brush would wear out, basically take 2 bolts out on this side, pull the bearing out that side, the brush just comes out, and away you go. If you want to do it in sections down below, then you basically take out this bolt and that bolt, and this whole assembly, well, you have to take the one pin out, the whole assembly would come out, put it on the floor, place it, come back up.
Hold on. Okay.
So basically, the brushes are in two main sections. Be the first 3 stop right here. They're all hooked in, so they all are adjusted by one turnbuckle right here. Then each individual one, after we're set for the production schedule, or if one brush wears out faster than the rest, then we can actually adjust each individual brush by the second turnbuckle here. And each one of these turnbuckles are on each brush all the way down.
Okay, anything else good to know?
Nope, that's about it.
All right.